In this lab, we'll investigate magnetic induction. Induction is a process that begins with a changing magnetic field. This field could be changing either because you have a moving magnet or because currents are changing. A changing magnetic field will, in general, mean that the number of magnetic field lines pointing through some surface will also be changing. This is called a change in flux through that surface. Anytime you have a change in magnetic flux through some surface, the loop created by the edge of that surface will have an EMF around it. If the loop is in a conductor, that EMF will cause a current to flow. Finally, this new induced current creates its own magnetic moment and magnetic field. This induced magnetic moment can then interact with the original changing field.
We'll see the effects of that interaction in the first part of the lab when we move conducting objects into a magnetic field and see that there's a force on the conductor. We'll also measure EMF directly, both induced by moving magnets and by changing currents. In the first part of the lab, you'll swing a conducting plate through the magnetic field of a permanent magnet. If you pull the plate back and release it, you'll see that it slows as it enters the magnetic field. You'll try different plates and explain the differences in their motion. In the second part of the lab, you'll drop a magnet through a coil and measure the EMF induced around the coil as the magnet passes through it. The coil is connected to the data acquisition box, which is set to measure voltage. The magnet is a long, permanent magnet. Just insert it into the plastic tube running through the coil and release it. In the last part of the lab, you'll apply a changing voltage across a solenoid and observe the EMF induced in a second external solenoid. You'll build the circuit so that current will flow from the power amplifier to the solenoid, from the solenoid to a 100 ohm resistor, and from the resistor back to the amplifier. The amplifier receives its input signal from the data acquisition box. You'll insert the driver solenoid into the pickup solenoid. You'll then measure the voltage induced across the outer solenoid by connecting leads across the solenoid to the A input of the data acquisition box. You'll simultaneously measure the voltage across the resistor by connecting the leads across it to channel B.